are live. There we go. Okay, today's date is 11/22/19. Okay, so here's our objective. Today we want to talk about the sum of a geometric series to infinity. Okay, everybody awake? Alex, you awake back there?
You got that all.
Okay, let me ask you an easy question. Easy question, okay? If I keep adding, now listen, plus 2, plus 2, plus 2, plus 2, plus 2, where am I eventually going to get to? Is it getting bigger? Plus 2, plus 2, plus 2. Is it getting bigger and bigger and bigger? Yeah. Right? So if we do something like that, it's going to go to infinity, right? What if I said we're going to do this? Subtract 5, subtract 5, subtract 5, subtract 5, subtract 5. Where am I going to? Negative infinity, right? So how do I get to a specific number? Well, let's take a look at it. So an infinite geometric sequence, you must multiply by a number smaller than 1. In fact, we'll do this little symbol here, and I'm going to go highlight that, okay? Okay. That's R. That's our multiplier. And I've got my multiplier has to be less than 1. But I've got this weird symbol here, right? What's that weird symbol? Absolute value. Because we could multiply by negative 1/2, couldn't we? Negative 1/2, negative 1/2. And that'd still make it smaller, wouldn't it? So if our number is between 1 and negative 1, it's going to get smaller and smaller and smaller. If my number is equal to 1, then it just stays the same. Here it gets smaller. So when we add, we want to make sure it makes sense. I want to keep adding smaller and smaller and smaller pieces so that the last piece I add in is nothing. I'll say it again. We want to keep adding smaller and smaller and smaller and smaller pieces so that the last piece I add is nothing, and then I can add them all up. If I add bigger and bigger and bigger and bigger pieces, right, it's going to go up to infinity. Or if I subtract or multiply bigger and bigger negative numbers, it's going to go to negative numbers. That's not an answer. So if I take a look at that whole thing, this whole thing has to do with a thing called convergent or divergent. So divergent means it's just going to go to infinity or negative infinity. Okay, if it's divergent, it's going up. In fact, that's a term that we use sometimes in behavior. He's a divergent child, or she's a divergent child. You ever heard that term? No. Oh, okay. Divergent. You guys got to take some psychology. A divergent child is a child that flies off the handle, right? Goes off to infinity, right? Not a very good kid to have around, huh? Now, if you're going to converge, you're going to then get closer. So to be convergent, you're going to approach some value. You're going to get closer and closer to some value. That's going to be a convergent sequence. So let's take a look at the following. I've got 3 sequences here, okay? Super easy. 1, 2, 4, 8, 32. It's getting what? Bigger and bigger and bigger, isn't it? Eventually, what am I going to go to? Eventually, with the dot, 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 it's getting closer and closer to infinity. So this one is divergent. This one's going to be divergent. Because it's just getting bigger and bigger and bigger, okay? Let's look at example 2. 0.9, 0.99, 0.999, 0.999. What's this one getting closer and closer to? 1. Everybody agree with that? It's going to be convergent. This one's getting closer and closer to the number 1. I agree. So this one's convergent.
Would it be convergent just because it's getting closer to number 1 specifically?
Yes.
Okay.
Yeah. So if it gets closer and closer to any number, where it's getting closer to 0 or 10 or whatever,
Okay.
it's zeroing in on a number instead of flying off to infinity
Yeah.
or flying off
Just
to
going
negative
out.
infinity. Yeah, totally right. How about this one? 50, 40, 30, 20. Now, this is a little bit of a trick question. Don't be tricked, but what do you think?
Divergent.
It is divergent. Now, why do you say that?
Because it's going down.
So what's the next number? 10.
Negative.
0, yes. So then it starts going negative. You guys agree? So then it goes negative 10. Then what's the next one? Negative 20. So some kids think this one's getting closer and closer to 0, but the problem is you get to 0, and what happens? You're going to still keep subtracting 10, right? Negative 20, negative 30, negative 40. What's this one going to?
Negative.
Negative infinity, right? This one's going to negative infinity. So this one's going to be divergent also, right? So if we were to start to add these things up, plus, 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 if it is, we're going to add these up, right? If we're going to add these up, this one's going to go to infinity, right? No sum. You ready? No sum. I mean, infinity's not an answer, right? But this one, if you start to add these up, plus, 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 you should get an answer, right? Because the very last piece you add is going to be like itty-bitty. And then this one, you keep adding this plus, plus, plus. This one's going to go up to negative infinity, no sum. So we need a formula, okay? So here's our formula, okay? Let's write this down. Let's put our formula down right here off to the side. So the sum to infinity, and I'm going to put a box around it. It is S of infinity. And I like the little infinity symbol there, okay? And I'm going to put it also on the board over here. It has to be geometric. S to infinity, okay, equals, all right? It is equal to A1 divided by 1 minus R. And I'm going to make sure we put the parentheses here so you don't mess up the parentheses, right? Okay with that? That's it. That's the formula. Pretty easy formula, isn't it? But, R must. The absolute value of R must be less than 1. Has to. Otherwise, this formula doesn't work. Okay? So here's my formula. Okay? This infinity, A1 divided by 1 minus R, but R's got to be less than 1. Because if you multiply by something that makes it smaller and smaller and smaller and smaller, then the last piece is nothing. That actually makes sense. If you multiply with something bigger than 1, it just makes it bigger and bigger and bigger and bigger. And what's the sum? Infinity or no sum. Okay, am I making sense? Okay, so let's check it out. Let's do it. So example number 2. I've got 10 plus 1 plus 0.1 plus 0.01, 0.001. Is it getting smaller and smaller?
Yeah.
So the last piece I add up should be nothing, so I should be able to add them all up, right? So, first of all, what's my R? What's R in this case? What's R? Anybody know what R is? What's my multiplier? Well, if you're not sure, we can always find R by taking the second term divided by the first term, right? 1/10. So R is, in this case, R is 1/10 or 0.1. Same number, right? Same number. And you can see that, right? Multiply by 0.1, multiply by 0.1, multiply by 0.1, right? So let's use our formula. What's my first term? What's my first term? 10. So my formula is S of infinity equals A1, which is 10, all over parentheses, 1 minus 0.1. And I'm just going to use my calculator, right? May as well. Use a calculator, so I'm going to go, okay, everybody see that? I'm going to go 10 divided by parentheses, 1 minus 0.1, and my answer is 11.11111, or 11.1 repeating, okay? So it does all add up to one thing, doesn't it? It's kind of cool. Okay, now example 3, 0.45 with a bar over it is the same thing as, 0.45, 45, 45, 4, 5, 4, 5, 4, 5, dot, 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 right? Okay, right? 0.45 forever. Everybody's with me on repeating decimal, right? Now, that could, or it could be, ready? 0.45 plus 0.0045 plus 0.000045 plus 0.00000045 plus dot, 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 okay? So it really is kind of the problem we've been looking at, isn't it? Right? So we can change this to a reduced fraction if we think, okay, this plus, you guys okay on how I got that, right? 0.45 and 0.050045, you guys can see that, 0.45. So now this is an infinity problem also. It's the last piece I'm going to add, a little itty bitty, right? So it is an infinity problem. What's R? What is R? Well, again, if you can't figure out what R is, take the second term, 0.0045, and divide it by the first term, 0.45, and you get, anybody know what that is? Well, those will reduce.
0.01.
Or 1/100th. Yes, 0.01. So the multiplier is 0.01. What's my first term? What's A1? What's my first term? 0.45. And I have a formula, don't I? So S of infinity is equal to A1, which is my 0.45 divided by parentheses 1 minus 0.01, right? Let's see what that gives me, okay? So I get parentheses, I get 0.45. Oh wait, isn't there another way to do this? Yeah, because I want a fraction, right? I'm running a little room. Can I squeeze this up here? I should have written smaller. So that's the same thing as 0.45 divided by 0.99. Isn't that 0.99? Which is 45/99. Because I want a fraction, right? I want a fraction. Bad is a fraction, but that'll reduce, right? Well, how do I reduce that? What divides into both of them? 9. So I divide that by 9, what do I get? 5. Divide that by 9?
That'll be 11.
I get an answer of 5/11. So it reduces to 5/11. Hey, check it out. Let me see if that is true, okay? 5 divided by 11. Hey, what do you know? Ha! Look at that. 5 divided by 11 is, if you could see it, there it is. 5 divided by 11 is 0.454545, right? Pretty cool. Okay, turn the page. Okay, find the sum. Oh, what's going on? Is it getting smaller? Is it getting smaller? Yeah, so it probably has a sum. It's getting smaller, smaller, smaller. Okay. So, but if I'm not sure what the multiplier is, R is always equal to the second term divided by the first term. If you can't figure it out, right? So let's figure it out. Okay, so I'm going to go -4 over -6, which is 2/3. Okay, got it? So that's my multiplier. So I'm going to use my infinity. S of infinity equals A1 over 1 minus R. I got R. I know what R is. R is 2/3. What's my first term? Yeah, so let's just use my formula. Is this easy? I hope so. So I'm going to go -6 over 1 minus 2/3. I'm going to do some fractions. -6 divided by 1/3. You okay with 1/3? Do some math. I mean, if Jay comes to your house and eats 2/3 of Mama's pie, how much is left? 1/3, right? And then that's the same thing as -6 times 3 over 1. See you guys, have a good weekend, which makes -18. So if I add all these up, it adds up to -18. Okay, number 4. We're going to go to infinity, right? So let's see, my first term is 4 plus. Let me make, my next term is really going to be 4/3. So my next term really is going to be 4/9. My next term really is going to be 4/27. Then 4/81 plus. How did I get that? I just plugged in numbers. I really did. I just plugged in numbers. I plugged in 1 and I got 4. I plugged in 2 and I got 4/3. I plugged in 3. I just kind of did it in my head. You get how I got that? And then I look at it and I go, what's going on? What's going on? What am I multiplying by all the way through? You're close. How about 1/3? I heard the 3. How about you, Julie? Okay, it's 1/3. So you guys, I'm multiplying. R is equal to 1/3, which, yeah, I kind of thought so because there's my R right there. You guys see my R right there? That is R. So is it getting smaller and smaller and smaller? Sure. We can find an answer. We can. What's my first term? A1 is what? So let's use my formula. S of infinity is A1 divided by 1 minus R, right? Which is 4 divided by 1 minus 1/3, right? Which is 4 divided by, so if Alex comes to your house, Seth, and your mom baked a pie and eats 1/3 of your pie, how much is left? 2/3, right? And with fractions, if I invert and multiply 4 times 3/2, I get 12/2, or 6. So all those pieces add up to 6. You guys have got to do a little bit of fractions. Sorry, that's the way it goes. Okay, last but not least, and this is true. When a doctor gives you medicine, the doctor's not really thinking that what he wants in your bloodstream is 400, but it's going to be higher because those traces of medicine are still in your bloodstream from a week ago, and a trace from a week and a day ago, and so forth. So all of those pieces of medicines for the whole week are still in bloodstream, just smaller and smaller pieces because they slowly start to decay. Right? So if they decay at 20%, then what's left is 80%. 80% is left. Does that make sense? All right, if you lose 80%, if you lose 20%, then 80% is left, okay? So, what we're going to do is this. I'm going to start out with 400. Then I'm going to go 400 times 0.8, 320. Then I'm going to multiply that by 0.8. It's 256. Multiply that by 0.8 times 0.8. I get 204.8. So I'm multiplying, I'm timesing. In this case, R is 0.8, okay? Multiply that times 0.8, okay, is a 163.84. And then watch. Just watch, okay? I'm going to go enter, 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 enter. So within like 2-3 weeks, that very first dose you took, it's not much of it left in your bloodstream, right? But there's still a trace. Just to let you know, which I know you already know this, that when people take drug tests, there's still pieces. So if you, I know none of you would do anything stupid, but it is true that if you are dabbling in things you should be dabbling in, a month later, they can still find traces of it in your bloodstream. Just let me know, okay? Because it decays slowly, but there's still pieces of it left. Enter, 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 enter. Oops. Anyway, it's going to stay there. So if that's the case, let's just back up. This is the 5th dose, right? Plus the 4th, plus the 3rd, plus the 2nd, plus the very last one you took. So this is the last one you took, bumped you up to 400, but you've got all these other pieces left. So this is an infinity problem. So what's it going to level off to? Well, certainly it looks like it's going to level off to close to 1,000, right? So 400 milligrams should level your bloodstream up to maybe about 1,000. You guys see that? About 1,000. So how do we do it? It is an infinity problem. S of infinity. Because we're going to assume that you take it forever and the little pieces go down to nothing, right? Is equal to A1 over parentheses 1 minus 0.8, because that's my multiplier. So in my calculator, I'm just going to go 400 divided by parentheses 1 minus 0.8, and I get an answer of about 2,000 milligrams is what it levels off to your body, which I think is kind of cool. So, and we got to be careful of that.